which would show us build on this concept of all the numbers that we have within Python. And this one will be 1.2.1. And the focus of this particular concept is to talk about more number types, right? Number types, and which we've seen, int, it's a little bit slow typing, decimals, or let's call it floats, and complex. All right, so that's what we're gonna see here. So now complex numbers. All right, so let's take this one step further. So in the previous lecture, in the previous concept, we saw how we can just print numbers on the screen. I'm gonna comment this out so that we can start from afresh here. All right, so now what we're gonna do here is we're gonna set some numbers. So we can say x equals 5. All right, the way we were able to set strings within for strings as variables in the previous lecture. If you check on that lecture, somewhere here or here, I'm not sure where that might show, you would see us being able to set strings, and we can do the same with numbers. All right, so I can go ahead and I say print x. All right, and guess what? Just skip that. I don't want to commit that to Git. I want to run it instead. All right, and it's gonna print 5, right? And you might say, why x? It doesn't have to be x. I can say ish, my ish equals, of course it's not 5, right? For those of you out there not 5 years old. All right, my ish print my age, right? So you can set any variable to a number. You can set any variable to a number. Now we can take this even further, right? We can say, let me just stick with x and y, just so, because in math sometimes you see a lot of x, y, and z and j and all of that. So let's say y equals 7.8, z equals, let's actually stick with y first. All right, let's say print y. All right, so it's gonna print 7.8 for us. Now let's try something else. Let's say z equals to 3j. All right, let's go ahead and print z. If I go ahead and run that, all right, what does it do? It prints 3j. All right, let's try 3p. All right, if I go ahead and run that, what do you think is gonna happen? Voo. All right, and voo means boo because it did not print. All right, so you're asking yourself, I took a number and I added p to it, it doesn't print. If I add j to it, it doesn't complain and it prints 3j, but why doesn't it print 3p? All right, so 3j prints, 3p prints. Let's look at one other one, 3i. All right, it doesn't print. So what is unique about j? Let's do 3a. 3a still doesn't print, but for some reason, let's say 5j or 5j. So what is unique about j that makes it print? But if you take any other number and you attach a letter to it, it doesn't print. But if that specific letter is j, it prints. All right, that's because there are different types of numbers in mathematics, and that's just simply represented in Python. Now, if this concept doesn't mean anything to you, it's okay. All right, not everybody is familiar with all kind of numbers. So this one we call them integers or whole numbers, right, which we're very familiar with. These ones are called floats, right, or decimals. All right, decimals. And this one is called complex numbers. And this is it's a concept in math, complex numbers, right, where you take your real part and your complex part, and then you have a complex number. If you're not familiar with complex numbers, just go on complex numbers. Just go on Google, on YouTube. You can just read a little bit more about complex numbers. If I do an image here, just to show you a complex number. So a complex number usually is a combination of they call it the real part, and then they call it the imaginary part. And that real part is simply, you know, a, and then the imaginary part is something plus a digit plus some letter behind it, right? So that's complex numbers. That's all I can talk about for complex numbers for now. But if you're curious, just search for complex numbers in mathematics and you can read a lot more about them. That's the kind of concept that's been translated here into Python. All right. So if I do print z, as long as this is a j, that's fine. There's no problem to it. All right. So that's taking us into the concept of what we call complex numbers. Let me actually modify number types and how to check them, because part of this lecture, part of this concept within this lecture is to also check the number types. And if you're saying, but Fru, you're just telling me this, like, how do I know? How can I just see something on the screen and know what the data type is, right? How do I just know that this is an integer, or just know what this is, or know what this is if I see any new number? All right, you can check that within Python. And the way you check it is, say you have a variable x, we can print x on the screen, right? So it's going to print 30 for us on the screen. But if you want to go ahead and check the type of that number, there is a function within Python that we can use. We can say type, and then x, we wrap that type around that. So what we're saying is print, and then the type, right? So we're wrapping this around this function, right? Let me zoom in again more. I think that's the most I can zoom. So print type x, right? So instead of printing x, so what this is gonna do is gonna print the type of x. So it's gonna tell us what x is. All right, and you can see here it says x is of type int, which means integer. So if there's a number that, or something that you're really not sure what it is, and you want to know what the data type is, that's what type means. They call it data type. You can just simply say print type of that number and you can say it. All right, and the next one we can do here, of instead of doing x, we can do print type of y and z, right? And you'll notice now that y and z. All right, so let me bring this back. So we have three numbers here on the screen. X equals 30, y equals 7.8, and z equals 5j. And we've said these are all different types, and this is what I wrote here. But if you want to verify that, you can actually say print type of x, print type of y, print type of z. And you can try it with any number you can think about. Write any number on the screen, decimal, negative number, whatever it is, and print the type. And if we go ahead and run this, we're going to see the type of this number. All right, so if I scroll down here, you see that the very first one, this one, 30 is an int, this one is a float, and this is a complex number. All right, let's change this. Let me put a negative there. All right, if I run this, it's still an integer, even though it's a negative number. So integer is not just positive numbers, right? You have positives and you have negatives too as well. So it accounts for that, right? Floats are just anything that has a decimal to it. And you know, a decimal is just a representation of a fraction, right? And then you have your complex numbers as well. So these are some of the number types that we have within numbers in Python. And these are the ways that you can go ahead and you can check what type of number it is you're working with if you're really curious. All right, now this takes us into the next segment of a concept that we're going to cover, and this will be concept 1.2.3, right? So now in this particular concept, we're going to be looking at mathematical operations with numbers. All right, so this next concept now is going to be taking us, instead of just looking at numbers and printing numbers and checking the types of numbers, can we actually take numbers within Python and do mathematical operations with those numbers? That's what we're going to be looking at here. And maybe I got that wrong. One, okay, so that's two. That should be two. Bear with me, guys. So that's concept number 1.2.2, and if you're checking into my Git repo, all right, so concept the 1.2.2. If you're wondering how I'm naming this, basically 1 is still module 1. All along we've been on module 1. 2, this is lecture 2, and dot 2, this is the concept 2. So you have a module, the lecture, and then within that lecture we have the concept. So if I go back one more, module 1, so this is module 1, which is Python basics. If you notice, there are many modules that we have coming up. All right, there are many modules, Python operations and data types and structures. So we're still on module 1, so this is still the basics. And then within that, we're looking at our lecture 2. So this is lecture 2. So this is saying module 1, lecture 2. That's what this 2 stands for. And then within that, then we're going 1, 2, and then within the lecture 2, there are many concepts that we're covering, right? Starting from 0, 1, 2, 3, 4, 5. So we're covering a lot of concepts, and right now we're looking at concept module 1, lecture 2, concept number 3, right? And you're saying, but 3? In Python, you start counting from 0. So if you're not familiar with that, I'll talk about that in a different video. All right, so let's go back into Studio, into our development canvas. I call this Studio, but let's look at our development canvas. All right, so mathematical operations within Python. So I'm gonna have to comment out. Just bear with me to do something. All right, so we can go ahead. What I just did there is being able to comment out the block of code, which you can do in Python, and I showed this in the previous video. So if I run this, nothing should happen because the code has been commented out. All right, so let's look at the next concept here, which would be mathematical operations in Python. So if you have 2 numbers, can we take 2 numbers and add those numbers within Python? Sure, we can. So let's say print, right? We take 3. We can just simply use a plus sign, plus 5, all right? And we can print that on the screen. So if you think about your mathematical operations, any mathematical operation that you might want to do in math, you can do it, right? I can say 3 multiplication, right? That should give us 15. All right, so that gives us 15. So if you think about your addition, subtraction, multiplication, all right, all of that, you can perform that within Python. So 3 minus 5, that gives us -2. All right, so all the mathematical operations that we can perform within Python. As a matter of fact, let me do a couple here. All right, so we can say 3 plus 1.25. Actually, let me not do that. Let me do 1.25. All right, we can do this. So think about Python could literally be a calculator, right? You can want to calculate something, pull up Python and simply just do this, and it can simply become a small calculator for you instead of using your phone or something else. All right, so very, very, very powerful. And we don't have to do just integers or floats the way we've seen here. We can also do, say, print 5 divided by 2. All right, we can also print that and see the value. 5 divided by 2 is 2.5. We can do more. I like to show multiplications. 3 times 3 point that. All right, so that should give us 9 point something. All right, 9.72. all right, so we can do our multiplications. Now we can also do modulus. If you know modular multiplication in modulus in mathematics, you can say print let's do 3 well, I'll show the modulus later. Let me show something. So 3 let's try this. All right, 1. So basically what this is saying is here is division. So 5 divided by 2, it was 2.5. all right, but this one is simply saying how many 3 divided by 2, what's the remainder. This is like modulo operator, right? In math, when you do a division, you take the remainder, that's your modulus. So if I did 11 mod 2, that will be 1, right? Because 2 can divide 10 and then 1 will remain. So all right, but if I did let's see, mod 3, then that should give us 2. all right, for our modulus. So that's basically a modulus operator. In mathematics, you can also do that within Python. So that's some of the basic calculations that we can do. There's a lot more of calculations that you can do in Python, all right, but this just gives us a basic. Literally take any two numbers and you can just, you know, use your basic math in Python and you can write out those numbers. Now what we're going to do here is